Climate. Reference table is not going to help us very much here. It's all stuff you need to know in your head. Let's go. Some factors that affect climate of an area. The proximity to equator. Basically, the equator is hot. Towards the poles as you get, are colder. So in this case, I had a picture here. Towards the equator is warm because the angle of insolation is always pretty high. As you go this way, it gets colder. As you go this way, it gets colder. Okay, most people tend to know that, but that is one of those factors that affect climate. Another one is elevation. It's colder at higher elevation, therefore mountains are colder, tops of mountains are colder. As my example right here is, if it's 77 degrees here, maybe it's 61 degrees up towards the top of the mountain. That's another one that most people tend to know or recognize before they even take an earth science class. So that's pretty straightforward. So for instance, what's the main factor that causes C to have a colder climate than D? So D is here, and there's a bunch of other descriptions here, but D is here. C, they draw it in the mountains. Therefore, the answer is C is at a higher elevation or in the mountains. And there you go. That's a pretty straightforward question. So those are nice. Another factor that affects climate is proximity to ocean. Okay, this gets a little maybe more complicated in that not something you necessarily know walking into this course. And water has a high specific heat. And what that means is that water heats up or cools down slower than land. So here I'm really thinking of oceans, okay? Maybe really large lakes, but really let's think of oceans here. And because water heats up and cools down slower than land due to its high specific heat, locations near the oceans will have cooler summers and warmer winters. So we say it moderates the temperature. So their swing between high temperatures in the summer and low temperatures in the winter are going to be much closer together. Okay? So they don't have that dramatic of a difference between their highest temperatures and the coldest temperatures during the year. And here is a good example from a question we had years ago. And it shows Virginia Beach and Springfield. And the question was, Virginia Beach experiences cooler summers and warmer winters than Springfield because Virginia Beach is located closer to the Atlantic Ocean. Orographic effect, sometimes called orographic lifting. Here we go. So this is the example of how you have this side of the mountain, the windward side of the mountain, will tend to be more precipitation. So why does this occur? So I'm going to try to show it to you. So as you have the wind coming this way, the wind's going to rise over the mountain. As it does that, the air will expand and cool, okay? And then once it starts going down this side of the mountain, the air will compress and warm. So let's show a step-by-step example here. So if you have air coming from the ocean to a mountain, first of all, in this instance, it's going to have a good amount of moisture in it. So this will probably has a lot of good source of moisture here. So if the air is 77 degrees Fahrenheit here, as it rises, it will expand and cool. So we see it cooling down here at 68. Side note, I could tell it's 68 right here in this example. That would be the dew point temperature because that's where clouds form. Back to weather. So that's just a side note. So 68, as one gets to here, maybe it's 61 degrees Fahrenheit. And then as it goes down, it's 75 degrees Fahrenheit. And here, maybe it's 89 degrees Fahrenheit, or even hotter. That's just my example. Notice that this is hotter than this, and this is hotter than this. And that's because it dumped a lot of its moisture, and that dry air will warm up more. Just as a side note. So this is what you get if I could label them. This area tends to be wet and cool, the windward side of the mountain. The leeward side, and even way off this way, is going to be much warmer and dry. So you can have often desert-like conditions over here. So a big mountain range, you have a sort of really warm and dry on this side, while the peak of the mountain and the windward side of it is going to have a lot of precipitation, oftentimes a lot of snow. It's a lot of ski areas are in this situation like this. This is why they get so much snow. So here is a question that asks that. Compared to A, what's the relative air temperature and average moisture at B? So compared to A, we're now comparing B. Notice this has the wind kind of shows that it's coming this way. And relative always means compared to. So we're going to say things like higher, lower, more, less, the same. That's what relative means. So the answer here is going to be B is going to be hotter and drier than A. Lake effect snow. Lake effect snow is cool for us in New York because we're one of the prime examples. Upstate New York is a prime location for lake effect snow, which is pretty cool. So here we go. This is how it works. This example, they're using Lake Champlain between New York and Vermont. And this is a good diagram, so I'm using it. usually this is about the Great Lakes for us, Lake Erie, Lake Ontario, but Lake Champlain works as well. So in the wintertime, because it's lake effect snow, what you're going to have is the air moves like this over the water. So let's think about what's happening. In that case, in the winter, the water, because water has a higher specific heat than the land, it will cool down slower in the winter. So in the winter, the water will be warmer than the air. So when the air goes over it, there will be, it will warm and there'll be evaporation so it picks up a lot of moisture. And then when it comes over here, and hits the land and then rises, it will cool, reaches its dew point, and you get a lot of snow over here. Okay, that's the general gist of how lake effect snow works. Here's another example. A Venus exam had this diagram, very similar. It has evaporation from the warm lake water as cold air comes over it. It hits the land here and usually rises. So in New York, this example is showing Lake Ontario. This is the Tug Hill Plateau, and this is the Adirondack Mountains. It hits the land, it rises, it cools, and they get a lot of snow, and they get dumped on with snow. Holy cow! Some of these areas get an insane amount of snow. Lake effect snow is super cool. So, for instance, this question had, this is a snowfall amount of this particular snowstorm over here, like near the Syracuse area. And then I think it asked what direction did the wind come from. But in this case, the wind kind of comes this way. But in general, the wind's always moving this general area here. So what I did here is I showed, and now I have Lake Erie here, Lake Ontario here. In general, the wind it always moves this way with a little bit of variation. Here's, Tug Hill Plateau, Adirondacks. You have the Buffalo, Rochester area here. And so these areas that I have highlighted in orange here, these are really the lake effect snow areas of New York State. They get dumped on with snow, and even along here too. So that's important to point out. Lake effect snow, super cool.